This is Craig, AC5KW, and this TC Aries training was written by Mark W5MAE. Another essential skill for an Aries responder is GPS navigation. You may be given a street address or a latitude and longitude to respond to, or you may be asked for your location in latitude and longitude. Map reading skills are still recommended, but many of today's commercial GPS navigation units provide everything you need for navigation. Most are relatively inexpensive, independent, low-power devices that run on 12 volts. When shopping for a GPS navigation unit, you'll want the following features: offline independent operation, on-device maps with street address geocoding, routing from your current location to the response location, support for entry of a destination location in latitude and longitude, display of the current location in latitude and longitude, and optionally the ability to modify the route to avoid obstacles, and optionally the ability to display latitude and longitude in different formats. The popular Garmin Nuvi GPS navigation units satisfy all of these requirements. Some, but not all, of the TomTom units satisfy the requirements. The Magellan units do not support latitude-longitude entry as far as we know. The Garmin Rhino units satisfy the requirements with some user interface awkwardness. The iPhone and Android phones satisfy many of the requirements, but cannot operate independently of a network. They are useful for everyday navigation, but will be severely handicapped if the cellular network is compromised. Many other GPS units are available and have varying capabilities. GPS references an Earth-centric location using 3 coordinates. Latitude measures the north-south axis as degrees from the equator to the true poles measured from the center of the Earth. It ranges from minus 90 degrees from the South Pole to plus 90 degrees from the North Pole. The equator is 0 degrees. Longitude measures the axis along the equator from the prime meridian, which passes through Greenwich, England, as measured from the center of the Earth. It ranges from minus 180 degrees to the west of the meridian to plus 180 degrees to the east of the meridian. Elevation measures the distance from an idealized spherical model of the Earth known as WIGS 84. There are 3 common formats for expressing a latitude and longitude: decimal degrees, degrees and decimal minutes, and degrees, minutes, and decimal seconds. A minute is 1/60th of a degree, and a second is 1/60th of a minute. GPS units may represent a location in one or all of the formats. Some units may require entry of a location in a specific format. You can convert between formats using a calculator. To convert from decimal degrees to degrees and decimal minutes, remove the fractional part of the degrees coordinate and multiply it by 60 to get the decimal minutes. To convert degrees and decimal minutes to decimal degrees, divide the decimal minutes by 60 and add it to the degrees. Hopefully your GPS unit supports entry of display of all 3 formats. When providing GPS coordinates via radio, it's a good practice to announce the format first and then the coordinates so the receiver will know what to expect. Austin is 30.2 degrees north latitude and 97.7 degrees west longitude. When a coordinate is specified as north or east, it is positive. When it's specified as south or west, it's negative. So another way to describe the location of Austin is 30 degrees, 12.0 minutes latitude, and minus 97 degrees, 42.0 minutes longitude. On the radio, the location would be given as my location in degrees and decimal minutes is 30, 12.0 minus 9742.0. Because the coordinates are radial measurements over a spherical Earth, the distance between coordinate values vary depending on where you are on Earth. Around Austin, a latitudinal degree is 111 kilometers or 69 miles. A latitudinal minute is 1,847 meters or 1.1 miles. A latitudinal second is 31 meters or 102 feet. A longitudinal degree is 96 kilometers or 60 miles. A longitudinal minute is 1,610 meters or 1 mile. A longitudinal second is 27 meters or 89 feet. The Global Positioning System, which is also known as Navstar, was conceived in 1973 and became fully operational in 1994. Russia, China, Japan, and European Union also maintain GPS-like navigation systems with various levels of capability. The GPS system is currently fully populated with 32 satellites. The satellites transmit low-power digital navigation signals at 50 bits per second, around 1.2 gigahertz and 1.6 gigahertz. The signals are very degraded by buildings and other overhead cover. Generally, 4 satellites must be received for an accurate location. Typically, 9 satellites are in view if the GPS receiver has an unobstructed view of the sky. It takes 30 seconds or more for a GPS receiver to compute a location after it starts receiving data from the satellites. The satellites send time, satellite position, satellite orbital data, and error correction data at a slow bit rate. Most GPS receivers attempt to reduce the time for an initial location by reusing satellite and solution data from the last time that it was operated. If the GPS is relocated a significant distance between uses, it will have to reacquire all of the satellite data again and take longer to produce the first accurate location. So consider buying a competent GPS navigation unit and learn to operate it with addresses and GPS coordinates. Then you will be better prepared to respond when needed. This is TC Aries Training.